Hello, I'm Tony Schiavone, Manager of Technical Services for the Rohm and Haas Company's Polymers, Resins, and Monomers Division. During the past 2 decades, we've seen waterborne coatings replace solvent-borne formulations in many industrial finishing operations. The change to waterborne coatings has forced industrial finishers to take a long, hard look at traditional application techniques. Most finishing equipment was originally developed to apply solution coatings. Can this machinery apply the new waterborne coatings, which are generally dispersions rather than solutions? Finishers are particularly interested in the spray application of waterborne coatings. Spraying is the most popular means of applying industrial finishes. If conventional equipment cannot spray waterborne formulations, many coaters will face major difficulties. As a supplier of vehicles for waterborne coatings, Rohm and Haas Company shares the concerns of your industry. If conventional spray equipment cannot apply formulations based on our products, we may need to develop products with different application properties. However, before taking any action, we have to find out whether there really is an application problem. That's why we decided to evaluate the compatibility of typical spray units and waterborne coatings. The firms who make spray applicators know more about this type of equipment than anyone else. So we arranged to have 5 prominent equipment manufacturers, Binks Manufacturing Company, Can-Am Engineered Products, the DeVilbiss Company, Graco Incorporated, and Nordson Corporation test an industrial lacquer based on a Roplex polymer with their applicators. I was present to monitor and help conduct each trial. What you're about to see is the results of these trials. We hope this video addresses some of the questions you may have about the spray application of modern waterborne coatings. Equally important, I would like this program to serve as the starting point for a dialogue between you and the Technical Services section of Rohm and Haas. We do not pretend to have solutions to all your problems, but we would like the opportunity to help in any way we can. For this reason, I encourage you to contact me personally if you think Rohm and Haas can be of service. Thanks for your attention.
In this testing, we generally left the choice of the spray gun and the test procedure to the manufacturer's discretion. We had only 2 requirements. 1, that the manufacturer choose equipment typically employed by coaters, and 2, that part of the testing should simulate an automated finishing line, the most rigorous application environment for an aqueous coating. To meet the second requirement, 1 portion of each trial consisted of a spray sequence in which the applicator was operated for 5 seconds and then allowed to sit idle for 30 seconds. The equipment manufacturer repeated this on-off cycle for as much as an hour or more. The results of each manufacturer's test were as follows.
For the first equipment trial, Binks Manufacturing Company chose a typical air atomizing spray gun.
Binks employed an air atomizing gun to spray the test lacquer onto a steel can and panels. To obtain the best spray pattern, Binks reduced the number 2 Zahn cup viscosity of the test formulation from 60 seconds as supplied to 55 seconds. The Binks automatic line simulation was noteworthy for its extended length. The 5 seconds on, 30 seconds off spray sequence was repeated continuously for 75 minutes. The coating went on very smoothly and uniformly. Even after 75 minutes, the spray pattern had not deteriorated. Note that very little buildup occurred on the tip of the spray unit.
Can-Am Engineered Products tested a low-pressure, high-volume applicator, a special type of air atomizing spray unit.
In the Can-Am trial, technicians employed a low-pressure, high-volume system. Of the 3 air atomizing units, this piece posed the most severe challenge to the waterborne coating. The continual discharge of hot atomizing air from the applicator creates a warm, arid environment in which the coating can dry very rapidly. To compensate, Can-Am reduced the test lacquer's viscosity to 45 seconds, lowest in the 5 trials. As with the other air atomizing systems, the Can-Am applicator performed well in the simulated automatic line testing. No problems in spraying or atomizing were noted. The slight crescent that developed in the spray pattern undoubtedly resulted from airflow in the booth, not from any deficiency in the waterborne coating. The tip of the spray gun remained quite clean.
The DeVilbiss Company conducted its testing with an air atomizing spray gun under very dry conditions.
DeVilbiss sprayed the waterborne lacquer under very dry conditions. The lack of ambient moisture in the application area made it necessary for technicians to thin the formulation to a viscosity of 50 seconds to prevent it from drying too rapidly. The DeVilbiss equipment performed extremely well in the automatic line simulation. The coating went on very smoothly and evenly. There was no change in the spray pattern at the end of the test. This gun showed less coating buildup on its tip than any other piece of equipment evaluated.
Although Graco Incorporated ran trials on both airless spray and air-assisted airless spray units, the airless spray unit was the primary focus of Graco's testing.
Graco, the 4th manufacturer in our study, chose to test an airless spray gun. This unit did not require any reduction in the test formulation's viscosity, but the coating was heated to a temperature of 80 degrees Fahrenheit to improve application. The heated coating went on very smoothly. Flow and leveling were excellent, as the uniformity and high gloss of the dried coating demonstrate. Graco tested both an airless gun and an air-assisted airless unit in the automatic line simulation. Both pieces of equipment were able to apply the coating successfully. In both instances, buildup occurred on the applicator tip. However, this buildup did not affect the spray pattern.
Nordson Corporation was one of the 2 equipment manufacturers to select airless spray units for testing.
The 5th spray applicator tested for our study was a Nordson airless unit. This equipment sprayed the lacquer at the supplied viscosity, 60 seconds, and the formulation was heated to 90 degrees Fahrenheit for better sprayability. As in every other case, the Nordson unit applied the waterborne lacquer very successfully. Equally important, the Nordson equipment did an excellent job in our automatic line simulation. A noticeable amount of coating material did accumulate on the tip of the spray gun. Nevertheless, this buildup did not affect the delivery of the lacquer to the substrate. The trials conducted by the equipment manufacturers clearly indicated that existing spray units can do a more than adequate job of applying the new wave of waterborne coatings. Additionally, every piece of equipment in this study successfully sprayed a waterborne lacquer in a very rigorous simulated automatic spray program. Even when buildup occurred, it had no effect on the spray pattern. These test results are good news for industrial finishers. Despite the fact that conventional spray equipment was designed for solvent-borne systems, these trials show that the applicators are fully compatible with typical waterborne industrial lacquers.